Hello everybody. So the today's question is partition string into minimum beautiful substrings. Basically the problem statement says that given a binary string S and we have to partition the string into one or more substrings such that each substring is beautiful. So now condition is the string is beautiful if it satisfies the two above conditions. What is this? It does not contain any leading zeros, and the second one is binary representation of the number is the power of s. So after converting the binary form to an integer, it should be a power of 5. So we have to convert this, so we have to return the minimum number of substrings in such partition. If it is impossible, return -1. A substring is a contiguous sequence of characters in a strings. So let's suppose this is the example. So we can partition array into this like this and one also. So converting two substrings, each substring into its integers and checking the above two conditions, like it should not contain leading zeros and it should be power of 5. So the effective solution will be this one. It is satisfying both conditions, like it is its binary equivalent to integer will be 5 and it is also 1. So 1 is the power of 5 and 5 is also power of 5. So second condition is this one also, like we have to split into single, there is no other way to split it. So the minimum substring will be 3. How to solve this question? Let us just jump into the solution of it. So it should be like at a particular string we can check like up to how many substrings are there which satisfy the above two conditions. So the conditions is we have to check the conditions. So basically like our enter button is not working. We have to refresh it first. Okay. So let's check function. There is a check function which checks whether it is a binary representation of 5 or not. So we give a string some t and we want to return whether it is true or false, return something. So let's check it is bool type and return true or false. Okay, I will write it later. First let us understand the problem first. Okay, so let's define an integer n will be variable of s dot length, which is give the total length of the string, and let write a function which give a recursive function, int function, which takes at a particular index which I am currently, and also takes the integer n, but here I am writing the ampersand, which by reference that will be fixed or copy will be not passed, and also a string, that part string ampersand s. Okay, so I have to check if I is less than n, then there is a valid substring will be there, otherwise we have to return 0. Why return 0? After that strings there is no any string can be formed after that particular index. And now from that string we can do anything. So problem according to program statement. So we have to check. So I am making a for loop int j equal to I, j is less than n and j plus plus. What does it do? It will take the every substring part. What will be substring? Like let the substring will be temp, creating a variable which is s of substring and takes the current index from which we want, and after the number of character in substring we want. So from I equal to we want every substring. So I will be take j minus I minus plus 1. Why it's plus 1. So if j will be equal to I, then its value will be 1, total value will be 1. So first character will be passed, means only 1 will be there. Okay, and I have to pass this substring to the check function whether it is a power of 5 or not. So temp function check. Okay, if check and passing this temp will be equal to true, then only we have to return some minimum number, minimum of some answers, where answer we can declare here only, like int answer equal to int max, maybe. Okay, int answer equal to int max, and again calling the functions from that particular index j, n and s, y j plus 1, sorry, n and s, and we have to again store it into answer, and answer will be equal to this. But have you noticed that the one condition is satisfied, but there are two conditions that it does not contain any leading zeros, so we have to satisfy that also. So let's check that one also, like if s of current value is equal to 0, then we can simply continue. We can't call the functions again, else we have to do this. Okay, so checking the function else part also. And now coming to this part, this is a sub part problem, and we have to mainly return a this is again one question that we have to solve it, given a string s, convert into a binary to the integer form, and then check again it is the power of 5 or not. So let's do that. So string, so containing n equal to s dot t dot length. Okay, taking each string, we can int answer equal to something 0, for int I equal to 0, so I is less than n, and particularly I plus plus. What we have to do, taking is character 0 or 1 binary form, and we have to left shift the bitwise operator basically, and adding. We can convert the binary to integer anyway, so I will shift answer to 1 bit left. Okay, and which is stored in the again answer. So every step we will shift the answers, and again if the current at a current index its value will be equal to 1, then we will OR with that answer equal to answer or 1 at this index and return answer. So that is not completed, we just completed the integer binary to integer functions. Before we do that, let us check this function whether it is correct or not. So to check that function, let's comment out this function, and again calling the function check by passing any substring like 1 0 1, like this can be 8 plus 1 will be 9, so our output should be of 9. Let's check what's the output is, whether it is correct or not. So our output is 1. Okay, we passed this one. Let's check why it is not correct. We left shift, sorry, answer should be left shifted. And now let's check again. Okay, our answer will be 9, and if we pass this function, then answer should be of 5. This represent 5, then 5. Okay, so our this function completed. How to check the power of 5 or not? So while answer percentage 5 equal to 0. Okay, if it is not 0, then it is not. Each time we will divide by the 5, and answer equal to answer divided to 5, divide equal to 5. What we will do? Each time we will check whether it is divisible of 5 or not. If it is not divisible, then what which means that is answer is not. If return, if answer equal to 1, then return 1, else return 0. Okay, so let's check this function also. Now we are giving bool value which checks that whether it is power of 5 or not. So it will be return 1 basically. So 1 means it is power of 5. If something like I will give you some pass more functions, then it will return 0 because it is not a power of 5. Let's consider 25. What is binary representation of 25? Is 16 plus 8, 24 plus 1, this one. Let's suppose this one. So this will be 125. Okay, so now the above function is correct, and let's complete this function also. Oh, so basically this one continues, and then else part will be there, and basically we have to return if, like checking if somehow we got the result that at a particular index we got the 0, then there should be not any answer. Return some maximum number like this one. And why we do that? And we have to return answer also. This is a recursive function, return answer. We can do that like this one also, like creating a temp variable, storing to we can optimize the space also, like putting this directly into this one. Let us run this function. So for running that, we can directly simply comment out this function, delete out this function, and directly calling function func, which takes argument current index should be equal to 0, n should be n, and s should be s. And let us check, run it, and getting the wrong answer. Why not? Yeah, what's the wrong answer will be? So there should be 1 plus. Why 1 plus? Because we have already covered one string, one substring. Okay, and if the value will be this one, then return -1. Okay, so we have to store in some variable like int x equal to this function, and check if it is not possible, if it is greater than equal to 1 if 9, and then simply return -1 because it is not possible. Else we can return the calling function x. And now we can see that our answer will be correct. Let's submit this question, and finally what will be happen with that not. So we successfully submit the question, but here it is accept. But again, if you see this is a recursive function which is calling again and again. Okay, so we can optimize it further by passing a DP array, which will do the memoization part. So let's do that part also, so that our code will be optimized, so the repetitive function calls will be not there. So how can you do that? Let contain a DP array of size will be n, and containing -1, which stores that whether function is already computed or not. So we have to check basically how to check that this function. If dp of I is not equal to -1, what does it mean? That I have already computed this function, this sub function part at that particular index. So why to calculate it again? Basically we can retain that part Okay, so at every computed value we have to store in some value part. So I have to, when I computed this, I have to store in that index, like at this index I have computed the answer ends. Okay, so let us run this question, and again we have to pass, so it will give some error, like it contains less arguments. Okay, again there will be some DP array here also, it gives some error. Sorry, S and DP. So we can this one also. Yeah, now the computation is completed, and let us check whether it is submitted or not. And here we get 100% bits. That's all about today.